So we want to understand how R and R inverse are related graphically. And so that's what this video is about. So graphically, obtaining R inverse from R amounts to a reflection across the line x equals y, or y equals x, if you will. So that's it, like 45-degree line that splits quadrant 1 into 2 equal halves. So what's happening is you're switching the first and second coordinate to go from R to R inverse, or vice versa. So your first coordinate becomes your second one becomes your first. All the points that are the same are things like the 5, 5 I had in my last example, where the first coordinate and the second coordinate are the same. If you switch them, obviously you have the same point. Right? Everything else changes. So 0, 0 will become 0, 0 when you switch it. 5, 5 will become 5, 5, etc. But so if you're switching the x and y coordinates, then on your graph, you're switching the x and y axes. And the way you're switching them is so that the positive x-axis and the positive y-axis switch, right? Because if you had a first coordinate 1 in R, then that will be the second coordinate of R inverse. It'll be 1, not minus 1, right? So the two positive axes switch, and if you think of it that way, you can see that just doing that, and with everything else in the graph on the plane acting similarly, it will flip it, the whole thing across that line y equals x. That line right there. And that's how I remember it. The positive x-axis goes to the positive y-axis and vice versa. So that's got to be that flip there. And everything on that dotted line, y equals x, if there's any point of the graph on that line, it's fixed by, in other words, it's the same for R and R inverse. Okay. So here's an example. This is just a graph of R. Remember, R is just a set of points in the plane. So this doesn't have a formula or anything. It's just a bunch of points I drew. Okay, now if I do the inverse, I want to just switch the x and y coordinates. Now, if I had notches for the 1, 2, 3, 4, 5 on the x and y axes, I could just figure out what some of the important points are, like this point here. Maybe that's like 1, 2. It depends on how I put the notches in, right? But say, for example, it was 1, 2. Then the inverse of this, R inverse, would have the point 2, 1. You just take the 1, 2 and flip it, 2, 1. And so that would be 1, 2, positive 1. It would be over here somewhere, right? And then you can do the same thing with this endpoint. Maybe do the same thing with this endpoint. And then you can sketch in between pretty easily what it looks like. Okay, some people can just see how to reflect it right away. Some people, it's best to just choose a few points, find their coordinates, and flip the coordinates, and then graph the point. So this is that line I'm reflecting across, which makes it look like the scale must be the same on the x and y coordinate. And those red dots, if you can see those, I made them a little small. Here, here, and here. Those points are points on both R inverse and R. They're what we call fixed points of this reflection, because the first and second coordinates are the same for all three of these, right? So I would graph those first, just to make it easier to draw. And then I did the endpoint, and then I decided I better put notches in to better demonstrate this. So you see, if I couldn't see this reflection very well, because I'm not very good at seeing reflections, right? I could just write out the coordinates, -2, -1, and then switch them, and it should be -1, -2, and then graph that point, and that's on R inverse. Okay, so it goes up here, and then it goes over like this, and then it goes over here to some point, and I'll actually find the coordinates for that. It's 1, 2, and so that becomes 2, 1. Graph that point. My scale's a little bit off. And then it goes to here, and then it goes over to here, which should be 2, 3. Okay? So see, I just do it little by little, and you can always get these right if you just do it little by little. If you see right away what it is and you're sure, that's fine. But if you're not sure, what I'm doing is basically checking some points. I'm just checking the most obvious points. Right? For now I'm doing the end point. 3, 2 becomes 2, 3, which is where I drew this dot here. That's 2, 3. It's getting a little cluttered, but that's 2, 3. It's the reflection of this one. My scale's a little off, but that doesn't matter. Everything you see will be on a grid, right? So, and then I just need to connect the interior part from here is basically a straight line to here, and then it curves on the opposite side here a little bit, and then it goes down here. So let's do that. Remember, this is not necessarily a function, it's a relation, so it doesn't have to pass the vertical line test. And the inverse of a relation, even an inverse of a function is not always a function, so it doesn't have to pass the vertical line test. So that's R inverse. Okay? So a function is a relation. Therefore, a function has an inverse relation, but that relation is not necessarily a function. Every relation has an inverse, because you can always take the points in the relation and just flip them. So that's the inverse relation, right? So every relation has an inverse relation. But remember, a function has to pass that vertical line test, right? And so if you think of that in terms of the points in the relation or in the function, that means that the first coordinate can't repeat itself. So you can't have the same first coordinate twice. Well, when you switch the x and y coordinate, that becomes you can't have the same second coordinate twice. But maybe the result is a function and maybe it's not, right? Because the first coordinate you could have a first coordinate repeated. Originally it would have been a second coordinate, but once you flip to the F inverse, right, then you could have two first coordinates that are the same, and so then it wouldn't be a function. I'll show you some examples, so don't worry about that right now. I'm just giving you the background a little bit. Okay? So they ask a lot of questions like this in mathematics always. Here's a function. Is the inverse relation a function? Usually we get a little sloppier and we say, here's a function, does it have an inverse? And the smart-ass answer is yes, every function has an inverse. It's just the inverse might not be a function. It might just be a relation. So the real question is, does this function have an inverse function? Or more clearly, is the inverse of this function a function?